Good morning, everybody, and welcome to Math with Mr. W. And our topic today are the rules of divisibility. Divisibility. What causes a number to go into another number evenly? Does 7 go into that number? Does 6 go into that number? Does 2 go into that number? How do we know? Let's find out. Now, this really helps the student to factor. It helps them to break numbers down because when they know these rules, they know that something goes into something else evenly. They can break a bigger number down. So let's take a close look at these and make sure that we don't spend a little bit of time on these, that we spend a lot of time on these. And I know that you're third grade now, but the fourth grade teacher and the fifth grade teacher should be spending a lot of time on it as well. And also through all the way to 8th and 9th grade, because it never gets lonely. It should never get lonely. It's a part of life. Makes things easier. So let's look at them. Number 2, the number 2. What makes a number divisible by 2? Well, it's even. So it's an even number. Everybody knows that. You can divide 4 by 2. You can divide 26 by 2 because the last digit is even. So the number 6 is divisible by 2 because it's an even number. The number 48 is divisible by 2 because the 8, the last digit of the number, is an even number. So even if I have a big number like 5,376, because this last digit is an even number, that means that 2 goes into it evenly. So my last digit is even. It's divisible by 2. Now, that's an easy one. Now, what makes a number divisible by 3? Divisible by 3. Well, this is a really great one. It's a really neat one. And we can start out small by just asking the students, which numbers do you know are divisible by 3? And they'll know 15 is divisible by 3. And they'll know 24 is divisible by 3. And they'll know that 27 is divisible by 3, and they'll know numbers like 36 are divisible by 3. So now let's take a look at these. If I add up the digits, 1 plus 5 equals 6. 1 plus 5 equals 6. 2 plus 4 equals 6. 2 plus 7 equals 9. 3 plus 6 equals 9. So if you add up the digits and the sum of the digits is a number that 3 goes into, then 3 goes into that big number. Isn't that neat? So this number right here, 5376, 5 and 3 is 8, and 13 is 21. I know that this number is divisible by 3 as well because the sum of the digits is 21. And 3 goes into 21 7 times. Isn't that cool? So I could divide 3 into this. You can take out your calculators and do it. It'll go evenly into 5,376. What a great thought. Makes it really simple. So on number 3, the sum of the digits are a number that's divisible by 3. Now, let's go to 4. So what do we do with the number 4? Its rule of divisibility is it, again, has to be an even number, but it has to be an even number more than once. It has to be an even number. 2 has to go into it twice. So because 2 times 2 makes 4. So that means you have to have a 2 twice. So I have to be able to get 2 into it twice. So let's think of the number 20. If I put the number 20 and I cut it down twice, I get 10. But if I cut 10 down by 2, I get 5. So I've done it twice. 2 times 2 is 4, so I get a number 5. So that means that 20 is divisible by 4. So I've got a number that's divisible by 4 because it went in by 2 times. Now, the number 5. What about the number 5? It's a very simple. Look at the end digit. The last digit is 5 or 0. Because 5 goes into 5 one time, and it goes into 10 twice. So because of that idea, basic idea, we have the rule of divisibility for 5 and 10. And then we've got it for 2,625. We know that 5 goes into that because the last digit is 5. All right, or 2,650. Because the last digit is 0, 5 goes into it. All right, now the number 6. What allows the number 6 to go into a number? Well, remember the factors of 6 are 2 and 3. So it's just like the rules of breaking numbers down. Since we need a 2 and we need a 3, since this number here is both an even number and the numbers add up to a number divisible by 3, that means that 2 goes into it and 3 goes into it. So if both of those go into it evenly, 2 times 3 is 6, so 6 goes into it. So that means that 2 has to go into it and 3. 2 and 3 go into it evenly, go in evenly. So both 2 and 3 must go in to the number evenly, and that means that 6 will go into it evenly. Number 7. 7 is sort of strange. Let's see if our youngsters can do it. So this is something I'm going to show to you. And if you feel your students can understand this or you feel comfortable with it, give it to them. So here we have 3 numbers that I know can be divided evenly by 7. Now, how do I figure this out if I don't know that? Here's what I do. I look at my last digit. Here's the 1. So I take the 1, just the 1, outside, and I multiply it by 2, or I double it. I double the last digit. So this becomes a 2. Now I have to subtract that from the remainder of my number. And that's the truncated version of the number. So I just have a 9, and I subtract, or I add the opposite now of 2, and I get 7. And everybody knows that 7 is a multiple of itself. So, wow, I know that 91 is a multiple of 7. It is. 7 times 13 is 91. Now, this is an even number. Doesn't quite look like a multiple of 7, but let's try it anyway. Okay? Again, according to our rules, we take a look at the last digit. Okay, so I'm going to peel off the last digit and double it. Makes 12. What's left? 26 plus the opposite of 12. That gives me 14. Is 14 a multiple of 7? It sure is. That means that 266 is. Now, I could even go further than this if I wanted to. I could take this number, peel it off, and double it and make 8. Now I have 1 plus the opposite of 8. And that gives me the opposite of 7. Well, -7 is a multiple of 7 because 7 times -1 is -7. So we can stop right here because we know that's a multiple of 7. We don't have to go this far. But if we did, we know that's a multiple of 7. And we know that this works. Now, 21, we know is a multiple of 7 because it goes in there 3 times. 7 goes into 21 3 times. That's a fact. But let's do this. We'll peel that off and we'll double it and then we'll subtract. We get 2 plus the opposite of 2. What does it give us? 0. 0. 7 times 0 is still 0. So that works. So now, 0 is a multiple of 7. So 7 times 0 gives me 0. And we're okay. So now we have 3 different things to look at. We have a 7, we have a multiple of 7, or we have 0. And if any of those happen to come up, we know we have a multiple of 7. These are small numbers, easy to understand. But let's take a look at a bigger number, 12,264. Here's our number, 12,264. Now, I don't recognize this to be multiple of 7, but I can test it by peeling off the last digit and doubling it to make 8. So I peel that off and make 8. And now, what am I left with? I'm left with 1,226. So I have to subtract or to add the opposite of 8. So what does that give me? 1,216. I don't recognize that to be a multiple of 7. But let's try this. I'm going to peel off the digit again. Same process. I'm going to double it. And I'm going to subtract the 12 from whatever is the remaining or truncated answer. So I take that and I get 105. Now, I personally recognize that immediately as a multiple of 7 because 15 goes into that 7 times. So it's 7 times 15. So I know that. Now, your students may not recognize that. So that's okay. They can do the same thing we did before. We cut this end one off and double it, making 10, and subtract it from the beginning. And we end up with what? 0. So we needed a multiple of 7, 7, or 0. And guess what we got? 0. So according to our program, we have a number that's divisible by 7. So you can take your calculator and just divide 7 into this, and you'll get an even number. Now, try it if you want to. It's fun. It'll take a while for them to catch on. Number 8. Well, 8 is an extension of 4. 4 times 2 is 8. So we now need 2 going into it 3 times. 2 has to go into it 3 times. So let's take the number 32. 32 divided by 2 is equal to 16. That divided by 2 equals 8. That divided by 2 equals 4. So we know we have 3 2's that go into it evenly. That means it's divisible by 8. So the rule for divisibility, 2 has to go into it 3 times. Now, the number 9. 9 is kind of like 3. Only this time, the digits have to add up to something that's a multiple of 9. So if I look at the number 1,575, now we know that that means a 5 goes into it evenly, right? But if I look at these numbers, 1 and 5, that's 10, and 7, 18. That means the sum of the digits is 18. That means 9 goes into 18 twice. That means this number has to be divisible by 9. I know that because the sum of the digits is 9 or a multiple of 9. So a number that doesn't even look like something that would be divisible by 9 is, simply because the sum of the digits, 6 and 12 makes 18. That means it has to be divisible by 9. Finally, we have 10. And 10 is real easy. It just ends in 0. The last digit of the number is 0. And we have a multiple of 10, or a number that's divisible by 10. Now, everybody seems to have some rules. Now, 7, to have your students really try and memorize your multiples of 7 to 12. And I will be giving out a pattern that will help them out with multiples of 7. So I'd like you guys to remember these. Make sure your students practice them. I know it'll help them with their factoring. It'll help them with understanding division and multiplication. See you next time on Math with Mr. W.